In this lesson, we're going to be looking at the derivative rules for sine, cosine, and tangent functions. So we're going to start off with some graphs that will look quite familiar from when you did the derivative puzzle. And so our top graph here is sine x, and it already tells us right down here that if we take the derivative of sine, we're going to get cosine. We're just going to explore that looking at these two graphs. So let's just take a look at when we're looking at our sine graph right here, we can notice that all along here, sine is increasing, and when it's increasing, we can see right here on the graph of cosine, it's positive, and that makes sense to us. Then in this next stretch, sine is decreasing, and we see in the corresponding portion on cosine x, we have a negative. And then we can keep doing this where we're increasing here on sine, and cosine is positive, and then we're decreasing, and cosine is negative, and then on our last stretch we are increasing here, and then of course cosine is, whoops, that was purple, cosine is positive when sine is increasing. So this makes perfect sense. If the derivative of sine x is cosine x, which it is. Now you may be disappointed that I don't have a proof for you, but tomorrow we will actually look at a proof that definitively tells us that the derivative of sine is cosine. For now, we're going to just accept it for this particular homework. All right, so now you might be wondering, well, what's the derivative of cosine? And it isn't exactly sine. It doesn't quite flip-flop back and forth, but the derivative of cosine actually is negative sine. So if you look at the graph of sine here, you'll notice that starting at the origin, instead of going up then down, we go down then up. So we've flipped sine over the x-axis, and let's just take a look at the same sort of comparison. So I'm going to do all the places where cosine is increasing. So increasing there, and here, and here. So we're increasing in 3 locations, and we'll notice that in those same regions, negative sine x is positive in these 3 areas. And then we can also look at all the places where we're decreasing. So we're decreasing here, and here, and here. And so we see that negative sine is negative in the corresponding areas. All right, so that's our other derivative rule, which is that the derivative of cosine x equals negative sine x. Now you'll want to memorize these two, and if you haven't done so already, you'll pull out your derivatives on your quick reference guide, and make sure you fill in that the derivative of cosine is negative sine x, and from the previous slide that the derivative of sine is cosine x. All right, so that leaves one more, the derivative of tangent. And this one, based on those we are going to prove, we should remember that the derivative of tangent could be rewritten as the derivative of sine x over cosine x. You should be thinking quotient rule right now and saying, oh, I know the derivative of sine x and cosine, so we can do this. So when we do the derivative, we're going to start with the bottom, cosine x, times the derivative of the top. The derivative of sine is cosine x. I'm going to take my time here. So I'll say times the derivative of sine x. Then I'm going to subtract the top times the derivative of the bottom, which is cosine x, all over cosine of x squared. Okay, so let's go in here. The derivative of sine we said was cosine, so we've got cosine x times cosine x minus sine x times negative sine x, which is the derivative of cosine, all over cosine squared x. So that gives us cosine squared x, and when we multiply negative sine x times negative sine x, we get plus sine squared x all over cosine squared x. Now, if you remember back to your identities and pre-calc, you should recognize this one on top as being 1 over cosine squared x. In our book, they're going to usually have it this way, so you can use your derivative of tangent being 1 over cosine squared x, but sometimes it is helpful to have it as secant squared x, and we'll accept either answer, so you should be comfortable with both. So on your derivative sheet now, feel free to put in that the derivative of tangent equals 1 over cosine squared x. All right, so let's do some problems. Here's our first problem, and these two problems are set together so that we understand the difference between the two. In this first problem, it's really one of the ones where we're taking the derivative of a constant times a function. And so you'll recall that that simply is the constant times f prime of x. Whereas this one, that 3x is on the inside. So this one down here, we have the inside equals 3x, and our outside function is the cosine of, and we can just call this u, and we can set this equal to u. So we have an inside-outside chain rule down here. All right, so let's take a look at what's the difference. So up here, if we just have a constant times a function, we simply write for our derivatives 3 times the derivative of cosine x, which is negative sine x. Or to just pretty that up, we'd probably write our answer as negative 3 sine x. Down here, we're going to take the derivative of the outside function first. Well, the outside function is cosine, and its derivative is negative sine of 3x. Remember, what's in here doesn't change when we take the derivative of the outside. And now we multiply it by the derivative of the inside, which is simply 3. And our answer could be cleaned up to negative 3 sine 3x. All right, let's move on to another example. All right, so in this next example, we've got x squared times sine x. Hopefully you're noticing that we've got two functions being multiplied. So you want to use product rule, and I would encourage you to pause and do this one and then check your answer. All right, welcome back. When we do this one, we should have taken x squared times the derivative of sine, which is cosine x, plus the derivative of x squared, which is 2x, times sine x left alone. And that is all there really is to this. If you wanted to factor out an x, you could, but it really doesn't matter too much in this one. All right, here's our next one. Now in this one, think chain rule. Think chain rule. And with that in mind, I would encourage you to pause and try it on your own. All right, welcome back. Hopefully you realize that if I have sine cubed x, that's really like sine of x cubed. So this time my inside function, which sometimes I like to call u, is sine x. And my outside function is whatever u is cubed. Okay? So let's take our derivative of our outside. That's going to be 3 sine x squared times the derivative of the inside. The inside is sine x, so that's going to be cosine x. And this is perfectly fine, but typically when we're squaring sine, we like to write it right here so that we don't need as many parentheses. And there's our final answer. All right, here's our next problem. Now, in this one, we have chain rule, but there are 2 layers. So chain rule with more layers. If you think you know how to do it, go ahead and pause and try it on your own before you listen to the explanation. All right, welcome back. In this one, it helps. Oops, I don't want to take the derivative yet. Let's do this first. Before we take the derivative, it helps to rewrite it just to make sure we understand what's going on. So I have sine of 5x, and that whole thing is cubed. So it's helpful to know what's really on the outside. So my truly outside function is this thing cubed. So we're going to start by doing 3 sine of 5x squared. Now my next layer inside is the sine 5x. And there, 5x is the inside and sine is the outside. So the derivative of sine is cosine. And I'm still going to have a 5x there. And now I'm down to my most inner function, which is 5x, and the derivative of that is 5. So we're done with this one, though we certainly could multiply this 3 and 5 and get 15. Put that squared where we normally would, sine squared 5x times cosine. Oh, there we go, of 5x. All right. Hopefully we're doing well so far. And let's go on to our next one. All right, so when we look at this one, we should be thinking quotient rule right away. And again, I would encourage you to pause and try it before I do this. All right, welcome back. When we use quotient rule, recall we take the bottom, tangent x, times the derivative of the top. So that's going to be 3 to the x, natural log 3, minus, now we're going to take the top, times the derivative of the bottom, which we said was 1 over cosine squared x, all over tangent squared x. It's not pretty, but we've done it. So that's a reasonable answer. Now, could we make this look nicer? Probably, but I don't think that's going to be our point right now. So I don't think we're going to worry about that too much, and we're just going to leave our answer like that. All right, so let's try another one here. I would encourage you again to pause this one before I do it. Welcome back again. When you looked at this one, hopefully you realized that the inside function is cosine theta, and my outside function is e to the u, if I consider this to be u up here. All right, so outside is e to the u. Derivative of e to the u is simply e to the u. So e to the cosine theta. The inside is cosine theta, so I just multiply times negative sine theta, and I am done with that one. All right, so we've got another one here, and go ahead and pause again. Try this on your own, and come back and check your answer. All right, when we did this one, our outside function we realize is the square root function, and so that's going to be 1/2 x cubed minus sine x to the negative 1/2. Take the derivative of the inside, 3x squared minus derivative of sine is cosine x. And there we go. That's it. You could rewrite it with 2 square root x cubed minus sine x and leave the 3x squared minus cosine x on top. And that's another nice way to write the same answer. Now, this one looks very familiar. Let's just go back and see what's different. The root of x cubed minus sine 2x, and this one x cubed minus sine x. So we've just added an extra layer with the 2. So go ahead and give this one a go on your own. All right. When you should be back now. When we did this one, it should look really similar. This first part is identical, except it's sine 2x here to the negative 1/2. Derivative of the inside, 3x squared minus cosine 2x, but now I have to multiply by the derivative of the inside, which is 2. Again, we can clean this up a bit. So we can just say, okay, well, this is 2 square root x cubed minus sine 2x, and the root down here, and on top 3x squared minus 2 cosine 2x, and that's that. So the answer looks very similar. The only difference is we have 2 x's in here and an extra 2 out there. Otherwise, it looks very similar to that one. All right, so our last problem in this lesson asks us to find the 50th derivative of cosine x, and I know you think that I'm pretty mean, but I would never ask you to actually figure out all 50 derivatives. Anytime you're asked to do something like find the 50th derivative, there must be a pattern. So let's see if we can find a pattern. We're going to start with y equal to cosine x, and we'll do y prime, which hopefully we have memorized already as negative sine x. We'll go for the second derivative. We know the derivative of sine is cosine, and this is just a constant, so negative cosine x. Third derivative, well, when we take the derivative of cosine, we get the opposite sign, so we're at sine x. And now the fourth derivative, which we write that with a 4 in parentheses, equals cosine x. And you should realize that, oh, wait a second, we're back where we started. So we should see now that every four derivatives repeat. This should kind of remind you of when you did I. Remember when you did imaginary numbers in Algebra 2 and pre-calc. Once you got to I to the fourth, you were back to the beginning. I to the fifth equaled I, and so forth. And you had this cycle. And what you did is you figured out, well, how many times does 4 go into 50? Because we're looking for the 50th derivative. So 4 goes into there, let's see, 12 times. That gives us 48. And this remainder of 2 is the important thing. So the remainder tells us what it's going to be equivalent to, which is to say that the 50th derivative is actually equal to the second derivative, which of course we could also write this way. The second derivative, which equals negative cosine x. All right, so hopefully that makes sense. We divide by 4 because we know every 4 is the same, and the remainder tells us how many extra we're left over with. Because if we came out even to the fourth, we're back to the original function. So the 48th derivative would be like the fourth derivative, the 49th would be like the first, and the 50th would be like the second derivative. All right, with that, you should have enough to be able to work on homework number 9, which is on page 136. And of course, this entire assignment also shows up on your assignment sheet. We'll see you tomorrow.